Welcome. In this video, I'm going to show you another example involving a sequence that either converges or diverges, and we are going to determine what it does. Let's take a look at the first few terms. All the odd terms will give us negative values, and all the even terms will give us positive values. When n equals 1, we have negative 1/3. When n equals 2, we have positive 1/9. When n equals 3, we have negative 1/27. And when n equals 4, we have 1/81. So you can think of this sequence as doing the following. The first term is here, the second term is here, the third term is here, and the fourth term is here. So even though it is oscillating between positive values and negative values, from our picture, I'm getting the idea that this is going to just keep getting closer and closer to the x-axis on either side. So my guess is that this converges. Let's use the squeeze theorem to show this. Now for even values of n, we'll always have negative 1/3 to the nth. So for even values, we'll have positive values. So this will always be at most 1/3 to the n. For odd values of n, we'll always have negative 1/3 to the nth power. It's always going to be bounded below by this. So for odd values of n, we end up with negative terms in our sequence. Now how can we use this to our advantage? Let's rewrite this. We have negative 1/3 to the n is less than or equal to negative 1/3 to the n is less than or equal to 1/3 to the nth power. And notice that the limit as n approaches infinity of negative 1/3 to the n is actually equal to the limit of 1/3 to the n as n approaches infinity. And this limit is 0. Therefore, the limit as n approaches infinity of negative 1/3 to the nth power also equals 0. So this sequence is convergent. And we use the squeeze theorem.